Okay. Yep. So do anyone have any questions on this, or do you need any understanding? Hope it was clear, right? So lambdas are helping us in, the main advantage is to see that your lines of code are simplified, and it's a replacement for anonymous class. That's the first thing that we should get it in our mind. And lambda syntax are the implementation for the functional interface abstract method, the single abstract method, correct? So any functional interface that we create, and we have a single abstract method in that, and for that single abstract method, we are trying to provide the implementation. Generally, it's an implementation for an abstract class, but that's exclusively only for the single abstract method. That's the rule that we will be having it inside the functional interface. So we can also create a custom functional interfaces by using the at functional interface annotation. And in the last class, we ended up discussing about the general functional interfaces. You said there are 43 functional interfaces, right? So the families are predicate, consumer, supplier, and function. Other four families of general function functional interfaces. We'll try to discuss about this probably in detail today. So the methods, the single abstract method that is available in each and every predefined functional interfaces are listed out here. Hope you'd have gone through the code once after I shared. Hope you would have taken from the GitHub. I knew that time is a constraint, but still we have to dedicate at least minimum 30 minutes per day or 1 hour per day in order to understand things. So practice, do a practice. I was about to share some exercises, but probably this week I'll be doing it. I'll be sharing more exercises towards streams. Okay, streams is very important. So this is a single abstract method that we have, and accept is another single abstract method, and get is another single abstract method for supplier, and apply is a single abstract method for function, right? Okay, so we'll get into some demonstrations of this. If in case if you don't have any questions, probably I'll take you to the demo of one by one. So let's take the example of consumer functional interfaces. So generally, if you look at the consumer, right, consumer, it means we are consuming the data, right? So what happens is it accepts the data, and it does some functionality by the data that you're providing in. So it's only an accepting, but doesn't emit anything, or it doesn't return anything. So that's the consumer is all about. So we'll see some small demonstrations for this consumer. So consumer is a functional interface coming from java.util.function package, right? So let's pick that. And the T refers that the accept method takes in a generic type as argument, right? Any type of parameter you can give. So what I'm going to do this time is I'm going to use, let's say, list of, yeah, list of string. I'm I'm making a little complicated the type. Okay, not a straightforward type. It's a list of string. So that itself is a type for consumer. So when you're providing an input for the accept method of the consumer functional interface, you're supposed to provide the list of string. So we'll just generate a list of string as such. So arrays dot as list, and provide some inputs. So let's say Sydney. We have USA. Okay, so we are just generating a list of string using this arrays.asList, I'm not taking you to any uh, streams. Streams we are going to discuss on Saturday. So Saturday we have a lot of things to be discussed. So I hope this line is pretty self-explanatory. I don't need to give more explanations here. Arrays.asList. So we have some set of strings out here. Now, what we are going to do with this consumer is the consumer is going to consume this countries, right? Now, technically speaking, I will convert this Sydney, USA. Okay, let it be like this. USA to an uppercase, and then we are going to see how this manipulation is going to take place. So uppercase country. Okay. So this is the consumer variable that we have created, uppercase country, and we are entitled to provide the lambda expressions. In place of anonymous, we are going for lambda expressions. And if you notice here, we are trying to provide multi-line of statements. Multi-line of statements, right? So we know that this is a lambda operator, arrow token or a lambda operator, and there is a parameter template, and then we have a body for the lambda expressions. That's all. Pretty simplified. Semicolon is something that we ensure that this is a end of this particular block, the lambda expression block. Now, the thing is, why I'm using this expanded blocks is because, as I said, it's for the multi-line statements. If it's a one-liner, I guess in the last class we discussed, there's no need for open and close curly braces as such. You can just write it as a one-liner statement and then consume the data and do some manipulation. Generally, what we do by consuming it in a one-liner statement and consumer is just sysout. For example, I'm saying, okay, you just do a sysout. So you can whatever you consume will be opted in as a parameter to the sysout, and the sysout will print that data. But this time it's not that easy. So we are just capturing it into an parameter. So if you see this particular, so this is something, an input that we provide, right? So what is the input that I'm going to provide in here is nothing but the countries. Countries is the parameter for the uh, lambda parameter. For which method are we implementing this? The implementation part is given for which method? For the single abstract method that is there available in the consumer, and that's none other than your accept. Hope you all will agree with this, right? Accept is the single abstract method that's available in the consumer, and the whole part what you're seeing here, the whole part what you're going to see here is the implementation for the single abstract method that's available inside your consumer functional interface, and the single abstract method name is accept. I stress it out here again because this is something very basic and very essential to be understood. The clarity should be there. Whenever you write an syntax, you should immediately recall that you're implementing an abstract method. I'm sorry, you're providing an implementation for the abstract method. But what abstract method is that? How do you identify that? What abstract method are we? Am I providing the implementation for? That can be decided only based on this function interface type. So it's consumer means the method that I'm trying to provide an implementation for is nothing but your accept method. Simple. Okay. So now let's go for the sorry the parameter of list. So it's list of string and then list. Can you tell me, is there any alternate way to avoid this style of type reference? providing a type, a data type. Can we avoid this here? I guess last week we discussed, right? So we don't need to provide the data type because we have that option called
Type
type,
reference.
yeah, type referencing, or it is more technically called as type inference, correct? Type
Yes.
inference. So technically speaking, there is no need for type, but this is how it looks like. So how do you, what is another motto for going for an lambda is to reduce your lines of statements as much as possible. So it's better to avoid this, correct? Now, will this be automatically inferred to what type? List of string, right? So let's say countries, list of countries, right? But if you notice here, how many parameter this method accepts as an input? How many
One.
parameter? Yeah, only one parameter, right? So if it's only one parameter, there is also another way that you can represent this argument by without providing the braces. Okay, the parentheses are not required. More. So what is that we are achieving? Can you guess what is that we are achieving out of this reduction of code? What are we achieving? Removing the data types, removing the parentheses, the braces, removing the curly braces if in case it's a one-liner statement. What is it we are trying to achieve in the Lambda syntax by eliminating? One is, yes, of course, to ease up the code. Another one is it gives you more of readability, correct? It's highly readable. It's more readable. It's understandable. But of course, yes, technical person alone can understand. That two person who knows about the Lambda can understand. But it provides a more of a readability of code. Readability of code is also one way of advantage that you can see on using the Lambdas. Okay. So what it means that we are providing a parameter, right? And a single parameter. So there's no need for parentheses to hold them. And then you have an arrow token and the body. That's all. So what we are going to do inside this, we are going to do some iteration work. So let's say inside this, we are going to have something called, let's say, for uh, I'm just giving a traditional way of for loop. Okay. Which we can avoid this, but just I'm trying to expand this list of countries dot um, size I plus plus. Okay, so I'm expanding more lines of code here. So we have the traditional for loop. Now inside the for loop, we can go for having this list of countries again dot set of I, and then you can say list dot get of I, which is of type string. I'm sorry, list of countries dot to uppercase. Okay, so what is happening? List of countries. This list of countries is going to carry this reference of this countries, which is Sydney, USA, German, and London. And we are iterating this collection using a traditional for loop, getting the size of the list of countries and incrementing the indexing. So initially, okay, this is given greater than, right? So less than. So 0 is less than the size of that collection. And then closely monitor that this is set method. Okay, the same object. I'm using the same object to the same position. 0, 0th position. So what was the 0th position is Sydney. So in that 0th position, I'm trying to update by getting that zeroth position of value, and I'm converting it to an uppercase and I'm setting it. I'll tell you why I'm making little complex set of code. We can even do it a different way. We can write a different algorithm to ease up this code. But anyways, we'll just keep it at this shape of code. Now, the first thing is the uppercase country. Okay, the uppercase country is a consumer type, and the consumer type is going to accept this countries. So now let's go for creating one more consumer. Okay, I'm creating one more consumer, and this time it's going to be a string. No, it's also again a list of string, right? So just have a list of string. Okay, and we can just say print consumer. Notice that one is uppercase country, another one is print consumer. So there are two jobs are involved here, job 1 and job 2. Okay, job 1, job 2 means I have two consumers. Two consumers of work is going to be done, but I'm going to merge both the consumer. I'm going to merge both the consumers. That is the actual outcome of this snippet of code. The reason I'm taking you to this consumer as two consumers is to merge both consumers. Why? We have a reason for it. Why we need to merge, why we need to learn about merging of two consumers. We have a reason behind it. We'll come to that shortly. Now here, so let's again give it as some list. Um, List of countries. Now this time it's going to be uppercase, right? So list of countries, which is of uppercase. And here again, you can use this. Now, inside this, you can say list of countries. So what we are trying to do is we are trying to print that uppercase. How do we print? We have a list of values. Probably you would have seen that, right? We have for each. Please make a note of it. For each method takes what as an argument? Consumer as an argument. What is the purpose of for each now? The for each method is actually going to perform the consumer operation. That is the meaning. So for each method takes the consumer as a parameter. This itself is one example for understanding the consumer. So what you are going to do inside the for each? I'm just going to print, right? I'm just going to print. So I can write a lambda, many things that you can learn from the single demo. Okay, I'll explain you one by one. Now notice that I'm going to take a parameter which is of string country. Now you will get only single country, and you can use this like this. And inside this system.out.println. Then you can print the country. Okay, so this is something which seems to be again more lines of code which we can reduce. I'll come to that. Now step by step. List of countries, number 1. It's going to contain the list of countries which is already converted to uppercase, correct? Then that list of countries is the parameter in this consumer definition, and this list of countries inside to that body of the lambda syntax, list of countries uppercase dot the list dot for each internal iterations. This is called as internal iterations, right? Internal iterations. What is this called as? Any idea? What is this called as? What this for
Traditional
is
for
actually doing? Yes, yes, please. Sorry.
traditional
Traditional. So it is external iteration, correct? External iteration. Why? Because we externally apply the iteration logic to iterate the list and then manipulate it. But here, are we using any for loop to iterate this list? No, we aren't. But that's inbuilt inside your for each method itself. So list can carry a for each method. The for each represents that to every element, for each element, the loop is going to be iterated. That is the meaning. So for each, but the for each takes what as an argument is the argument is going to be the consumer, and the consumer is going to take this each element as an input, each element as an input. That is the meaning. So this itself is an example of consumer. It's a lambda expression. See, now what you're learning here is binding lambda expression, binding lambda expression, lambda expression, binding lambda expression to a method parameter. Correct? This is a very important statement to understand. One method parameter itself is one whole lambda expression. See, what generally we will pass to a method. Let's say, for example, add method. What is there in the add method? Int a, comma, int b. Correct? It's an integer type. Let's say I have show name method. The show name method will take what as an argument? String name. So what this method parameter is? String. What is this particular method parameter is? Int. But look at this parameter. For each. For each method parameter is what? What is for each method parameter is?
Consumer.
Consumer. Yeah, means it is parameter is functional interface, correct? That's how you need to say. Yeah, you can say more specifically consumer, but what consumer is? Consumer is a functional interface. So from Java 8 onwards, methods can accept, functional interfaces. But that functional interfaces is not just an object that you pass to it. Instead, you are passing the whole lambda syntax itself. Whole lambda syntax is going to be passed as a parameter to the method. That's what is happening here, right? So understand that the for each method takes the consumer. The consumer is a functional interface, and the functional interface syntax, the implementation would be the lambda syntax. That is the meaning. Okay. Now, in this snippet of code, if you have any questions, please let me know so that I'll give explanations.
Sir, for each inside the parameter is an functional interface, but we don't explicitly declare the functional interface annotation, and we didn't write interface and the single abstract method, right? How it is Java compiler, how it is
For the inside the for each method?
Yeah, string country, you told it is a functional, the method itself we are passing as a functional interface, but we don't explicitly write anywhere that functional interface annotations with the interface and a single abstract method. How this Java compiler?
No. I guess you're okay. Okay, let me take you. Let's go dwell into the for each. Okay. What is there in the for each? What is the parameter for the for each?
Consumer.
Consumer. Very good. So what is consumer is?
Consumer is a functional interface.
It's a predefined functional interface coming from the general functional interface. What it is going to. So why do I need to create a consumer? Consumer is already there, right?
No, sir. I thought for each in the sense like for each loop which we use in generic Java. So just we are getting a list of objects and we are automatically it is iterating, but it's not coming from.
No. For each is a special method introduced only from 1.8.
Java 1.8. Okay.
Yeah, 1.8 Java. The for each method is introduced for applying on your collections. List is what? List is a collection, correct?
Yes.
And for that list object, you can apply for each, and the for each will take what as a parameter? The consume.
Yeah. Yes.
Consumer is a predefined function interface.
Mm.
You got it?
Yes. Yes. Got it. So
Yeah.
for each, like previously in the previous version also Java it is there, sir. But instead of the
No, no,
typical,
no, 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 no. That for each is, it's not spelled as for each. It will be like this.
I think
For
I think that
uh,
is enhanced
yeah,
for.
yeah, that is enhanced for loop. Yeah, it is called as for each loop. Yeah, it is actually called as for each loop. Conceptually, it is called as for each loop. So it will be like this. This is what you are saying, right?
yes, instead of traditional
This is,
approach
yeah,
we can.
this is this is introduced in Java 5. Yes, of course,
Yes.
this was introduced in Java 5, but this is looks more similar like a traditional. But the only thing is we are excluding that this ways this style of parameters. Instead, we
Yes.
just give that countries and then it does an internal
Yes. Yes.
uh, movement to the indexing. Automatically, it keeps moving to the indexing and
Yes. Yes.
halts once it comes to the end of the index. That is also a for each, and it is more technically called as it is enhanced for loop. Okay.
Yeah.
Or we call it as a for each loop also. Correct. Yes, it is a for each loop. But conceptually, we'll call it as for each loop. Similar thing is what is happening here. But this is the function, the function name. This is not a for actually. This is actually a function. Inside the function, what happens? It is an iterable, right? Inside the function, what they use? If you look inside the for each function, what they are using? They are using again that enhanced for
For
loop,
which
correct?
enhanced for loop for
Ah,
iterating the results. Yeah.
yes, correct. Instead of we doing that enhanced for loop and doing it, you just better call the for each method and they will do it. Just pass the consumer uh, template. That's all. Job is done.
Yeah.
You're
Yes.
getting it?
Yes. Got it.
Yeah. So what is this for each? For each is coming from where? For each is coming from the iterable. Iterable.
Yes.
Iterable is an interface. Okay. Yeah.
Yes, sir. Understood. So I just related with the
Correct.
1.5 for which it is.
I understood that. I understood it. Now, what was that I was explaining is directly you can pass the lambda expressions into the parameter of the for each method. Okay.
Yes.
But if you don't want to do that, you can remove it. If you want to keep it separated or isolated, then what we have to do? Consumer, correct? String, let's say cons equals this one, correct? Now what we have to pass in the for each? Any idea? What is the parameter for the for each?
Consumer cons.
Parameter for the for each is consumer type. Do we have a consumer type here? Yes, just now we have created cons as a consumer type. What the cons is containing? The whole lambda expression. So you can forward that cons variable here, correct?
Yes.
You do it this way, or it's better to just straight away punch in your lambda expression. Java 8 will accept. Instead of storing it in separate consumer variable and then passing that variable, or you can directly punch in the lambda, it's up to you. But the style of approach of passing the lambda to a method directly is also possible. That's the learning that you're getting here. Okay. Any doubts on this? Okay. So now we have two consumers here, right? So one is uppercase country, another one is print consumer. Now, how are we going to merge them? How are we going to merge these two? So to merge them, we are going to use the first thing, that is upper consumer. Okay. Upper consumer. Come on. Uppercase consumer. I'm sorry.
Uppercase.
Uppercase consumer. I'm sorry. Uppercase country. Dot. What is the method? Accept. That is the first consumer, right? This is your first consumer type. So you need to call the accept method, and the accept method, what do you need to pass? The countries, the list of countries that we have created, correct? So now the countries is forwarded. Great. But what this consumer does, consumer is consuming these countries These countries will get stored in the list of countries. What is the operation that's happening inside this consumer? What is
Uppercase.
it is only doing the uppercase conversion. But is there any sysout is happening inside this consumer lambda block? Are we doing any sysout? No.
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 So when you call this consumer and forward the countries, it will only perform the uppercase conversions to that existing list of countries. Correct. But the next step is the this list of countries which is converted need to be forwarded to the next consumer after performing the operations. It has to be chained. So to chain it, we are going to use a logic called, okay, we have this uppercase dot accept, right? Instead of that, uppercase dot country dot and then, okay, we have a method called and then, and in and then you're going to pass the print consumer, join it, okay, then you're going to use accept, and accept with what countries. Now what we are doing is we are joining two consumers, consumer 1 join with consumer 2. So what will happen here when you say and then you accept, how this logic is going to work?
The consumer will be printed in uppercase.
Correct. The consumers will be printed in uppercase. Yes. This uppercase will be processed and the uppercase country have to be printed. But how the logic will work? That's what which we need to learn here, right? So how the logic is going to work and then what it is trying to do. What this and then is doing. The and then is doing, the first job is the and then will call the caller. Who's the caller? Who's the caller for this method? And then method? Uppercase country. Correct. So quickly what it does is it goes to the uppercase country and forwards this list, and the forwarded list will be manipulated to what? Uppercase.
Uppercase.
Correct?
Yes.
Step one is that. Step 1 is and then method will call the caller first. Step 2, what it has to do? It has to call the parameter. This is parameter of the and then, right? Parameter print consumer will be called. While it is calling, it has to pass the manipulated list of countries to this consumer, and the list of countries of uppercase is going to be manipulated by printing it. List of countries uppercase is going to be manipulated to print it. That's all is technically happening. So step 1 is caller call. Step 2 is the parameter call. Okay. Can we chain it? This is called as chaining. Okay. This is called as lambda chaining. You can have one more consumer. Okay. You can write consumer 3. What you can do? You can say uppercase country dot and then print consumer dot and then consumer 3 dot and then you can keep going. So you can keep chaining lambdas with help of this and then. Now the question comes from where this and then method comes. Uppercase country is what type? Uppercase country is a consumer type. So in that case, this and then is a part of which interface?
Consumer interface.
Correct. Consumer interface. Very good. So consumer is already a functional interface. Functional interface means it should carry only a single abstract method. Then how come this suddenly an and then comes? If you would have noticed the last time while I was explaining, you could have understood that there was a presence of and then method. This is the accept. This is a single abstract method, right?
Yes.
You scroll down, you can see there's an and then. And then is not an abstract method, and then is an default method inside an interface. Default method which takes the definition. What is the rule for interface? What is the
Should
general rule
have
for
only
interface?
definition.
Yeah,
Definition.
no, it should have only
It should have only
declaration.
abstract methods.
Abstract method, correct. It should carry only the abstract, right?
Yes.
It should carry only the abstract method. But suddenly we have this method with definition. I hope probably you would have seen this while you were working with Java project recently. Java 8 have started accepting methods with what? Default in interface.
Default.
So the default methods can have definitions. Can have definition. You're getting it? See, now you should understand practically that why Java 8 have suddenly started to accept default method. The reason is they have to support the lambdas effectively, and that's the reason they brought the default methods. And also these methods are going to help us in backward compatibilities. When we go for collections, you will understand that backward compatibility issues are addressed by bringing in default methods. We'll discuss that probably on Saturday. What is that backward compatibility is all about. But right now you just notice that the interface have started accepting default method. And then is that and then is the method that we have? Yes. Okay. And then is the method and accept. That's all. Only and then is there. Internally, you can do some logic is happening, but I'm not going more deeper into it. But you understand that it's a default method. We can also cook up like this, not an issue. We can also create our own custom function interface and use these kind of an and then operations. But right now, we don't need to go deeper into it. So that's what is happening. But one thing that you have to notice is what is the return of the and then? What is the return of the and then? Is again a consumer, correct? Is again a consumer. So that's what is happening here. Uppercase country dot and then of print consumer. It actually, when you call this and then, it does the job of joining. Okay, you can see that accept of t and then after dot accept of t. So technically what is happening is they are actually returning a final lambda which is of type consumer again. Return type is C. How they have narrated this code. The code narration seems to be a complete lambda, and the lambda syntax are of type what? Consumer. It consumes some type and accepts it. Okay, and they are internally calling accept, and they are using after dot accept because the parameter is after here. So what is that happening is the caller accept and the parameter accept both are co-joined together and returning a consumer. So that's how in deeper it works. Okay, so finally, what is the outcome of this? What is the outcome of this part alone?
Consumer.
Very good. The final outcome of this syntax is consumer object, but that consumer object is having all the threaded part. Uppercase country and print consumers both are co-joined and returning it in the type of consumer again. And with that consumer object, we are calling what finally? Accept. And accept, we are throwing that list object. So that's how it is actually working in internally. So let's see how this is going to be provided as an output. Let's see if this is going to have any meaningful response. Of course, you can see all are uppercase, right? All are uppercase. But what we provided was in lowercase, but now you can see it is all in uppercase. So what happened here technically is both the consumers are co-joined with the help of and then uh, the consumer method and forward the list. What if in case I don't want to do this? Show me a simplified code. We can do that. Let's go for printing the consumer. That's all. Print what? I want to print the Sydney, USA, German, and London. That's all I want to do. So in that case, what you can do is print consumer dot, you can say directly accept countries. What will be the output of this? Can anyone guess? What is the
It
output
will
of this line?
exactly print. Without you uppercase, it's simply
Correct.
written the list.
Without the uppercase, it will just, I'm sorry, without the uppercase, it will just accept that list. And what is the option here? It's just going to print one by one element. It's going to print. That's all. So if I run this, you can notice that the output is the lowercase. The first character is in uppercase. That's fine, but it's just lowercase. It's not converting it. But if I co-join it, so lambdas can be chained. That is called as chaining lambdas. I used to ask these kind of questions in interview. Okay, but people tend to not respond it. 80% of the people I've experienced, people will not able to respond to this question. But they, after I reveal the answers. So in interview, the one thing that I do is when I interview people, what I do is for all the questions what I ask, I will give the answers to them. Okay. So after revealing the answer, they will get to know that they have used this concept in their project, but without understanding that they have used it. But after revealing the answer for my question, they will understand and they will sync that the code that they have already written in their project will get screened in front of their eyes. So the thing is, whatever you work on, please try to understand more deep into it. You have to go more deep into it. And then, so APIs have to be completely ripped out and understood. So you have to go deep into the API classes and see what it is all written. That's something very, very important. Okay, only then you'll be having a learning, long lasting learnings. Okay, and clearance of interview will be pretty easier. There might be much more complex questions will be there. That's fine. So everyone are not going to have a response for all the 100%, right? Not necessary, but at least the essential part that you should know. So chaining lambdas are very, very important. Please make a note of it. It is called as chaining lambdas. So how do you do that with chaining lambdas? With the help of and then method. Any questions on this? Please do let me know. So now if I run this, you will notice that your outputs are going to be in uppercase. Quite good, right? Any questions?
Sir, one question. Uh, so the interface has only abstract method, so till Java 1.8, but that has been broken only for Lambda or
Till
any other.
till 1.7, not
1.6.
1.8.
Yeah, yeah.
Correct.
When the 1.8 came, they have completely changed that rule. So
Correct.
the only reason is Lambda or any other reasons also applicable for
The
that.
primary reason is lambda. Since they brought lambda, see when they bring lambda, it's not just about the lambda alone. Okay, don't think from the lambda is is the key source. Along with lambda, they also brought something called streams. Correct. You can use streams with lambda. Okay, streams API you can use with lambda. While you're using streams, okay, while you're using streams means the streams is applied on what? Collections. Okay, but if you're not aware what streams API which I'm talking about, that's okay for now. Just understand this. They brought lambda. Okay, they brought lambda. Lambda can be used in streams. Okay, streams are applied on top of what? Collections. Correct. So in this flow, what happens is actually you're trying to nurture this lambda to your collection via streams. Collections API introduced in 1.8 or earlier?
Earlier.
Very good. So collections API is a large API, right? They
Yes.
might have some hundreds of classes and interfaces. That itself is less I'm talking about. Now, all those classes and interfaces should support what? Streams.
Okay.
If streams are supported to collections of the existing one, streams should support what? Lambdas. So when collections API, which is already there in 1.7, which is like, let's say, for example, you have some collection classes, X class, that X class till 1.7, they don't know what is streams and they don't know what is Lambda. Is that correct or not?
Yes, correct.
Okay. Now coming to 1.8, suddenly I'm bringing a new API introductions and language change like Lambda and Streams API to the collection means the whole collections API should be reinvented, correct?
Correct.
Now I should not do that. Don't reinvent the whole collections. Instead of that, you can support with default methods and add all the functionalities wherever required. And you will just want to use that functionality into the existing 1.7 classes. All the classes, okay, all the class or whatever the interface, it doesn't matter. They will make use of this default. Let's say, for example, okay, I have a X interface in 1.7. Okay. If I have X interface in 1.7, if I suddenly want to provide a functionality to make the Lambda to support inside the interface, what I can do, I can write one default method, right, and define it. If I'm not doing it, if I just add an abstract method, like not a definition, for example, I'm not giving it as a definition, it's just a abstract method. If I add the other classes, right? The other classes which are extending this or implementing this X interface will all get impacted, correct? Because you've added a new abstract method. Do you agree or not?
Yes.
X interface, C1 class, C2 class, C3 class is all implementing X. This is the approach in 1.7. In 1.8, they say that this X interface should provide the support for Lambdas. So they are adding one abstract method, A1. Now, all these classes should implement this A1 or not?
Yes, it should implement.
Yes, because the rule is any number of abstract method in interface should be implemented in the class, correct? But
Yes.
now what they are saying is this will be a major impact because in collections there are hundreds and hundreds of interfaces and classes are interrelated. To avoid that, it's a backward compatibility. That's where the backward compatibility comes in. Now, instead of leaving it as an abstract, I will give it with the definition to support the Lambda, and the method need not be overwritten in other classes
Yes, sir.
because it will just get inherited like a normal inheritance, but that is from the interface because the method is already defined. The method is already defined. Okay. This is within the API of collection. But think about you have your application. Okay. You have your, let's say you have your change management application. Okay. If you have a change management application, which is already written in 1.7, you want to migrate the change management application to 1.8. Inside the change management application, you would have used all the collection classes and interface, correct?
Yes.
Now, when you're bringing it here in 1.8, suddenly if there are some 6 abstract methods are introduced in 1.8 collections due to the Lambda, what do you have to do while you're migrating? In your application, whatever the 6 abstract methods have to be overridden again, correct?
Yes.
That can be avoided because those 6 abstract methods are not abstract methods anymore in the interface. Instead, they are giving it as what methods?
Default.
Default methods with the definition. So it is not forcing you to change your existing application. You can quickly migrate it without any backward compatibility issues and just go ahead and use this default method as an inheritable method. If you wanted, you use it. Otherwise, you don't need to do it. I will show you a analogy of that on Saturday for this
Okay.
exclusively on default method and static methods.
Yes, sir.
So the understanding is, yes, why they need to bring this default now? Not just like that they brought. The main reason to bring it is to support Lambdas. When they started to support Lambdas, they faced a lot of what issues? Backward compatibility issues.
Backward compatibility.
Resolve the backward compatibility issues. The only choice that they felt was to introduce default methods. And they came for static methods. The reason is you need not create an instance and call it. You can just use the interface name and call this. So no need to use it inside your classes. Static methods are not going to be used inside the child class. Okay, that we'll discuss that anyways on
Yes, sir.
Saturday.
Yes, yes, got it.
Show the demo, you will understand. But yes, of course, you need to get the clarity that why they brought in the default is for to support this Lambda and avoid the backward compatibility issues. Yeah. Any other question?
No, sir. Why I asked this question is like that. This many years they have kept an rule that is break, that is
Correct.
broken.
But this is a valid point, right? It's officially valid. Of course, it's not just about thinking that it's reducing backward compatibility. Officially, this will support us. Why should we have the rule saying that in interface there should be only an abstract method? Because we had some reason behind it. Okay, not to have any implementation, because it gives you a set of what to say, a policy or a rule. Okay, it just sets some rules and policies through the interfaces and we need to follow them. But right now there might be challenges of backward compatibilities and that can be overcome by having this feature. But if needed, you use it. Otherwise, you don't need to use it.
Yes.
That's all. It's optional. It's optional. Depending on the scenario, you can make. I'm sorry, you can make
But
use of
there
it.
is an option to use if we get a scenario.
Correct. If there is a scenario that occurs where you want to enforce this with the default method, yes, you go ahead and define it. That's how it all works. Okay. So that's what the functional interface and the consumers and then is all like this. I'll take another 10 more minutes. Sorry for taking your time. I'll quickly go ahead and create one more demo for functional interface. Okay, that's going to be a little simplified. Why I'm giving you multiple demos because you can persist this information for a long run. So a quick demo on this. So for what interface we saw, the ready-made, available, predefined, consumer, right? Now we have one more family, right? What are the families we saw? Consumer, predicate,
Supplier.
supplier, and function. So what we have just saw was only the consumer. Now what we are going to see is function. So what functional interface abstract method is? Apply. Consumer, what we saw? Accept. What is a single abstract method that is there in the functional interface is apply. So in the functional interface, how I'm going to use this is we're going to use again similar logic. Okay, but this time it's going to be function. Okay, how many parameters does the function takes? How many type of generics that the function takes? There's two. Why? Consumer took only one, right? You all remember? Consumer took only one generic, but now two generics. Why? Input and return, correct? I hope last week we saw this, right? Functional interface method is apply. Apply method take an input and it provides an return. But accept what it does. It only accepts the input. But what is the return type? Return type is void. Correct? So that's what the difference between a function and a consumer is. Okay. So in the function, we are going to say integer, return is going to be an integer. So input is also an integer, return is also an integer. So I'm going to say times 2 equals. Okay. So I'm writing a code for functional interface, the apply method. Okay. The implementation for the apply method. So I'm going to use input. The input is integer. Okay. The integer is taken in a parameter called e into 2. 2 times. Okay. 2 times of value. Times 2 means 2 times of value. This is one functional interface. Functional interface 1. Okay. I'm going to create similar like in consumer we did, right? I'm going to create one more function interface. Function integer, comma, integer. Now I'm going to say squared. Before what we did? Times, 2 times of what? 2 times of a given value. So let's say 4, 4 into 2, 8. 8 into 2, 16. Okay, but now it's going to be squared. So E into E time. So this is squared, right? This is functional interface 2. So how many functional interfaces that we have created? 2 functional interfaces of functional interfaces we have created. 1 and 2. Now what we need to do? We need to merge them if needed. If needed, you merge them, or you can just execute them independently also. If you want to do a separate, if you want to see a separate output. So let's say system dot out dot println of times 2 dot apply of 4. What is the output? Hope you can expect, right? Now 4 is 4 into 2, 4 times 4, 2 times of 4 is 8. Okay, so if I say 8, then obviously it's going to be 16. Correct? So we are getting that respective output. You have one more functional interface. If you want to use them, you can use them. So now in place of apply, I'm going to use squared. What is the output? 8 into 8, 64, right? Yeah, 64. 8 into 8, 64. So now it's squaring. So we can call them individually also. Okay. So when you pass this value, this is an input. The input is manipulated, and it's how many line of statement it is? One liner of statement. So what is missing there? What is missing in this one liner of statement? Anyone
Open
can
and closing braces.
open and close curly braces is not there. Plus what is missing?
Semicolon.
No. That's fine.
Sorry, that
return statement is return keyword is not required. When return keyword is not required? When you have one liner of statements. But if you can expand this, right? How we can expand this line? Any idea? If I want to expand this, okay, open and close curly braces. If I use open and close curly braces, then what is mandate? If the method takes and return, you need to use the keyword called return e into 2. Agreed?
Yeah.
Yeah. Now what I'm saying is, hey, we don't want to expand that line of code. Can you just make it as a one-liner of statement? Yes. If you make it as a one-liner of statement, it will not expect this return, and it is not advisable to give return. Otherwise, it will end up with a compile time error. Which one would you prefer? The later one or the current one?
Current one.
Current. Highly readable, understandable. Correct? But the person who knows about the functional interface of apply, which takes a return, can understand this line. Otherwise, they won't understand. They can't understand. They might think that there is no return here. Whether the return is there or not, how do we presume it? Only when you know that the method has a return type. So if you get into the functional interface, the functional interface is carrying a method called apply. Apply is carrying what type? Return. Return of anything. Okay. So that's the difference. Okay. Now what I wanted to explain here is I want to co-join them. Okay. So times 2 dot, okay, and then here also see you have and then, like how in the consumer we merged, the same way here we are merging the function. Okay, you can merge them, and then what do you have to do? Squared. Can you predict the output? Apply of 4. Can anyone predict the output exactly? I explained you the logic, right? What this and then does.
64. First it called the caller, then it up. Then it
Correct.
makes
First it calls the caller and then it calls the
parameter.
parameter and then the apply method of the value. Correct. So what is the output?
64.
So as per the times 2, it
64.
is 4, right? Yeah, correct. So first it calls this times 2. 4 value will be the parameter. 4 into 2, 8. Correct. Then the parameter, which is squared. 8 is the parameter in turn. So 8 into 8. Expected is 64. Okay. So let's make it as 8 instead of 4. So 8 into 2, it's 16. Correct. 16 into 16. 256. Agreed?
Yes.
Now, I have one more question. One last question. With that, I will end up because I've taken more time of yours. Instead of this, instead of and then, in functional interface, we have one more choice called compose. There's a method. Compose is a default method. Okay, I'll take you there. See, compose is a default method. And then is a default method. You have something called identity. This we will use it in a static representation, not to be discussed. And then in compose. Compose, what the compose is going to do. Any idea?
Frame the output, sir. Compose.
Compose the output.
Framing. Oh,
Framing. Yeah.
frame.
It's only a slight difference between and then and compose. Both does the same job, but a slight difference which will throw a different output. I'll run this, okay? Before what we got 256, right? Now see what is the output. 128. Why 128? That's what we have to investigate. Why 128? The reason is when you use compose in place of and then, the compose, the first priority will be on parameter, not on caller. Okay, so
Squared will do first, followed by 8.
yeah, so
Apply.
now what happens is the compose will provide the priority to squared first, the parameter. What is the parameter job is 8? 8 into 8. What is the output?
64
Correct.
into 2.
So 64. Then only the compose will call the times 2. Times 2 is what is the output, that input that will be provided for the times 2? 64. 64 into 2?
128.
That's what the output is. So, and then operation will ensure caller is called first and then the parameter. Whereas in compose, the parameter is called first and then the caller. This is the difference between and then and compose. Both are doing what job actually? Both are doing
Merging the functional interface.
correct. Lambda joining lambda, right? Merging, joining the lambdas. Or we call it as chaining, I'm sorry, joining or chaining lambdas, right? It's chaining it and then also chains it. Compose also chains it, but the only difference between and then and compose is and then gives a priority to caller first and then the parameter, whereas the compose gives a priority for parameter first and then provides the caller. But if you notice in the consumer, you never had the compose. Consumer had only what? And then. Okay. There's a specific reason because it only consumes the data. It's not going to return anything. So they have just made it straightforward to have it in the and then. So you can think of how you want to use them among the and then and compose. Okay, but most of the time we will be using only and then. That's how the approach will be. But additional functionalities, if in case there are any specific requirement that you need to provide the priority for parameter, then you can go for the choice of compose. But both compose and then is what method? Default method. Yeah, inside which interface? Functional interface. And functional interface single abstract method name is what?
Apply.
Apply.
Oh, sorry.
It takes the input and it also provides the
Output. Return. Output.
return. Is that clear? If any questions, please let me know. I'm halting here. I'll just take only the questions now, probably another 5 minutes of time. It's already 9:10. So we saw two things today. One is consumer, another one is function. The same way we have it for predicate
And
and
supply.
supply. So supplier is reverse of consumer, right? Consumer is consuming it. Supplier will not consume anything, but it will just return something. Any questions, please do let me know.
So far, we saw one default method uh, in
Functional.
our function interfaces.
Correct.
So, can we have a number of default methods, sir, based
Yes,
upon
of
our
course.
requirement?
Yes. Yes. So inside an interface, you can have as many number of default methods you wanted. No limitations. N number of default methods, N number of static methods. Do you know one more thing that what can be accepted in interfaces other than this? Probably these are generic things which you should have prepared during your interview time also. Java 8 started to accept default methods, static methods. That's all fine. But there is one more thing that got introduced in interface in Java 9. Do you know that? What it is in interface? In interface, Java 8, you can have default method, static method, and abstract method. If it's a functional interface, there can be only one abstract method, but n number of default method and n number of static methods. If it's a normal interface in Java 8, you can have n number of abstract methods, n number of default methods, and n number of static method. Will you agree with this or not? Can you agree on this? Functional interface, the rule is one abstract method, n default method, n static method. If it's a non-functional interface, normal interface, you can have n number of abstract method, n number of default method, and n number of static methods. Okay, that's the rule. But from Java 9 onwards, added to this, you can also have private method, not a default method, just private method. Okay, and private static method. Private method and private static method. Why private method and private static method got introduced? Any idea? Inside an interface. Henceforth, you can also use private method and private static method. What could be the reason?
You can achieve encapsulation in the interface itself.
Correct. Encapsulation, hiding things essentially. But what is the need? Why should I provide this?
It is restricting the implement. They are restricting the implementation.
Correct. So you cannot override this. You cannot inherit this. Nothing can be done, right? It can be used only within the interface because it is explicitly provided as.
They don't want to expose this method to other classes.
Correct. But why should I have this unexposed method inside an interface? Interface means I should use it in the class. Why should I use it in an unexposed fashion? So it is same like local access. How many default methods we can accept in interface?
N number of.
N number. Very good. So when we have an access to n number of default methods, okay, default methods can have definitions, right? So you can have some 100 lines. Now you will write one more default method which takes some 10 lines of code. Okay. Assume that there are three default methods. Okay. And plus one more default method I'm adding. Okay. All the three default methods will call this one default method internally. It is making use of this default method for some reason. But the class which is implementing that interface will have access to how many default methods totally? Class which implements the interface have access to how many default methods?
4.
4. Very good. 4. 3 plus 1. But actually this default method is used in all the three. You need not give this default method access to this class, right? So we can make use of this as what? Private, not a default method, just a private method used within the default methods for their business logic. Because the reusability, right? Code reusability. You have some 10 lines of code. The 10 lines of code logic need to be reused among all the default methods. Then you can mark that method as a private method inside an interface, so that reusable logic method will not be applied in
In
external
other,
class. This will
other
not be
class
accessible in
implementation.
external.
So
Correct.
instead of 4, 3 can be implemented.
Correct. But they need some logic, like they want to connect to the database, connection establishment or whatever something is required. You can write it in private method, and the private method, the connections can be taken, make use of in the default method. But the default method alone can be accessible in the implementation class. So that's the reason in Java 9 onwards, they have started to accept private method, not a default method. You will use the keyword called private. Generally for default method, you cannot have private. Default methods need to be exposed outside, so you cannot make them private. And static method can be private, so that you cannot access it outside the class. Otherwise, static methods are inside interface can be accessed outside the class. So this much things are there in interfaces actually. Okay. Okay, I'll just stop here. Anyways, we'll discuss more on Saturday. Hope if you have any other questions, please do let me know. Do anyone have any other question? So the answer is yes. An interface in Java 8 can carry n number of default methods, n number of static methods, n number of abstract methods. But functional interface alone can carry single abstract method, n number of default methods, and n number of static methods. Hope I have answered for your question.
Yes.
Yes, sir.
Any other question?
No, sir.
Okay, great. So probably I'll share this file. I'll be committing it back to the GitHub. You can take it from there, and we'll catch up on Saturday evening. Okay. Yeah.
Sure.
So thank you
Thank
all.
you, sir.
Yeah.
Thank you.
Thank you,
Have
sir.
a great day.
Bye.
Yeah. Thanks. Bye.